Let's draw a truth table. I tell you right now, this is going to be a 3-letter truth table because it's coming from the optional exercises in your book. And if, when you're looking at these exercises, these do not look like what you did for the second part of the homework, you did not do the second part of the homework correctly. I'm going to show you the long way first and the short way, but if neither of those look like what you did for homework, you did the wrong part. Go back and take a look at 2.4.2, not 2.4.1. But anyways, back to this. Let's say that we had P and Q, arrow R, therefore P arrow R. And what I'm going to do is I'm going to replace the main operators on each side and put them in red instead. How do we know that this is the main operator? Remember, the main operator cannot be in parentheses. On the left side here, all we have is one premise. The and is in the parentheses. It can't be the main operator. The only other option is the arrow. So that's what the main operator is. On the right, it's P arrow R. The arrow is the main operator. So those are going to be the columns that we're going to be looking for once we get our truth tables going. Now we have 3 letters on this side, a P, a Q, and an R. So that means we need 3 rows over here. A P row, a Q row, or a P column, a Q column, and an R column. When it comes to the order, since we have 3 letters, we write 4 T's first, followed by 4 F's. Then we alternate 2 T's, 2 F's. Then we alternate T and F for our base column. The base column is the alternating of T's and F's. Then we want to plug these into everything else. So go ahead and bring the values over, plug them in. Again, if you feel very comfortable, you don't have to do this. If you're not comfortable or you're prone to make a mistake, just fill things in. Graphing paper is also nice for this, by the way. So let's start on the right side. And on the right side, since it's an arrow, we know that arrows are true everywhere except where there is a T arrow F. Oh, that's wrong. That's supposed to be true, and that's supposed to be true. What I'm going to do now, though, is I'm going to erase these F's and I'm going to put them in red instead. Why? Because what we're looking for by row is a row where we have all true premises but a false conclusion. That means I actually know that the only rows I need to look at are these 2 rows. But I'm going to complete the truth table on the other side as much as I can. So for this, I want to know where the P and Q is true and false first. So P and Q is true if both of the pieces are true. Otherwise, it's false. Then we get to do the arrow. We do the arrow using this column and this column. An arrow is true so long as we don't have T arrow F. So that's true. That's false. No, true. And then I'm going to do the same thing here. In this case, I'm using red since there's so many T's, just so I know what row I don't have to worry about. Because if I have a false premise, it doesn't matter if I have a false conclusion or not. I want all true premises and a false conclusion. Then the question is, for either of these rows, do I have all true premises and a false conclusion? And the answer is yes. For this row, what I end up finding is that I have a false conclusion here, but a true premise over here. As part of your homework, it says, tell us what the true values are for the variables that make the argument invalid. So we are telling you that the argument is invalid. To figure out what those true values have to be, look right there. This argument is valid where P equals true, Q equals F, and R equals F. Now, a thing to note is this is a rather long truth table. It's 8 rows long. There's a shorter way to do this, and I'm going to demonstrate that now. So to start, let's start by writing out our problem again. So we have P and Q, arrow R. Therefore, P, arrow R. And then I'm going to use blue to represent the values that I want to force the pieces to have. In order to show that an argument is invalid, I need all true premises and a false conclusion. That means the main operator in my conclusion needs to end up being false. It also means the main operator in my premise, or if there's several main operators and several premises, each of those main operators needs to be true. This then becomes a bit of a logic game, where we have to figure out what would the pieces have to be in order to make the main operator come out as false and the main operator come out as true. Let's start with the conclusion. I recommend that you always start with the conclusion. When we think about the main operator, we see that it's an arrow. Well, let's scroll up for a second. Let's go all the way back to our table. When we look at the arrow table, we find the only way to make an arrow false is if we have a true antecedent and a false consequent. So, we actually know what value used for the variables that we can assign. Namely, in order for this arrow to be false, P needs to be true and R needs to be false. So remember, what we're trying to do is we're trying to assign values to P, to Q, and to R. Well, now we know that P equals T, we know that R equals F, but we need to solve for Q. In order to do that, we can hop back onto the left side, we can hop back to the premise, and we can fill in the values that we now know, and see if we can work towards figuring out what Q has to be. So in this case, P we know is T, R we know is F, and we know that we want this arrow to come out being true. So let's think about our table again. We know that an arrow is false only in those cases where it has a true antecedent and a false consequent. As such, what we don't want is we don't want to end up with this and over here being true. Why? Because that would give us T arrow F. And we don't want that. What we want instead is F arrow F. Because F arrow F is true. And we want our premise to ultimately be true. So let's continue to think about this. We know that R is false. Because we need this arrow to end up being true, we can't have the antecedent end up being true. If it were, it would give us T arrow F, and that's bad. As such, we want the antecedent to be false. So let's take a look at the antecedent. The antecedent here is an and statement. That means that we want this and statement overall to end up being false. So let's take a look at the pieces. When we look at the pieces, we see that one of the pieces is already true. Well, for ands, we know that if it's T and T, it's true. But if it's anything else, so T and F, F and T, F and F, all of these equal false. We know that we don't want this. So we already said we want a false antecedent up here. So let's look at our options. Could we get F and F? No. Why? Because the P is already true. So we have to say of these two, which thing can we end up forcing the Q to be? Well, we already know that P is true, so this is out as well, because that's telling us that P would be false. So we know we want it to look like this. We want a T and we want an F. In order to spell this out in a slightly different way, let me write it out completely now. So let's see what happens if we have T and F, arrow F, therefore T arrow F. Well, this would give us a false conclusion. T and F is false. F arrow F is true. So this would indeed give us all true premises and a false conclusion. That also gives us a value for Q then. Q indeed must be false. So let's take a look at what we did. Instead of doing an 8-row truth table to try to figure out which row represents the values, we can solve it this way. This is a bit more of a puzzle, but for some folks, they find that they like this a little bit better. Let's run through a few more of these examples. I'll do it the long way, and I'll do it the short way. So the long way, this one's going to be number C. Again, we have 3 letters for a truth table. And this one says P arrow Q, P arrow R, therefore Q arrow R. So notice here we have 3 letters, but we have 2 premises. So let's go ahead and put our main operators in a different color again. In contrast to the last truth table we did where we just had 1 premise and 1 conclusion, here we have 2 premises. So we're going to want to take a look at both of these columns at the end, and we want both of these columns to be true while this column is false. First, let's get the rest of the truth table set up. We need 3 columns, P, a Q, and an R column. We do 4 T's, 4 F's, 2 T's, 2 F's, 2 more T's, 2 more F's, then we alternate. Again, this gives us all the possible combinations and possibilities for the truth values for this argument. Then we need to fill in the pieces. Let's go on to Q. Then R. Now we can start solving. Let's go ahead and actually start with the conclusion though. So for the conclusion, we know that given that the main operator is an arrow, it's going to be true anywhere that we don't have T arrow F. So that's true, that's false, that's true, 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 false, true, and true. Again, I'm putting the falses in red since I want us to know which rows we need to concentrate on when it comes time to figure out which rows, which values of P and Q and R give us an all true premise but a false conclusion scenario. But now we need to go finish the premises. Let's do P arrow R first. That's true, that's false. I'm putting that in red so we can ignore it. True, false, true, 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 true. So you can already see that we're going to actually end up ignoring this entire row because we have 1 false premise there, but we'll come back to that later. Let's do this one now. That's true, that's true, that's false, true, 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 and true. So now to figure out what the values are, we want to find a row where we have all true premises and a false conclusion. I usually start over here because this will tell me where are the rows with a false conclusion. So we can take a look at this row, for example. And we ask, does this give us all true premises but a false conclusion? And the answer is no. Why? Because this is a false premise right here. So instead of doing that row, let's do a different row. Let's do